This video is covering section 1.1, Introduction to the Practice of Statistics. Statistics provides a great tool to answer your question. Do people favor or oppose raising the minimum wage to $15 an hour? Um, do people live longer in the country with higher GDP? Do tighter environmental regulation in U.S. states result in a lower median income within the state? Is higher smoking frequency associated with higher percentage of incidence of lung cancer? How many hours Truman students sleep? And so on and so on. You can kind of realize the range of the question is very wide, from economics, health, finance, sociology, linguistics, psychology, and political science, and many other areas. Now, our question is, how can we answer this question? Right? In short, we probably need to collect some information, and typically we call that data, and describe that data, summarize that data, and figure out what the story is from the data, and then draw a conclusion from that information so that we can answer this type of question. Saying that, actually, what we just described, how to answer the questions, is what is actually statistics all about. And as you can see, one of the very common definition of statistics is the study of collection, describing, and drawing conclusions from information. So statistics can actually help you to make those type of decision. Um, the population, there are three different words here that are very commonly used in statistics. The population in statistics means all unit of interest, which is a little bit different from what we typically use the population, the word population. Um, Unlike the general definition of population, in statistics, it can be people, sometimes it can be objects, sometimes it can be events. So it's not always people, but it can be actually different things. The basic definition is just that everything of interest, the whole group of interest will be called the population. So for example, say how many hours Truman students sleep. So in this case, the group of interest, the whole group of interest is Truman students, right? So the population would be the entire Truman students. Variable is a characteristics or property of the unit in the population. In the example again, the variable is the sleeping hour, right? So, and the sample is a subset of a population. We call that sample. And there's a little drawing here, and you're going to actually see this drawing over and over again. Right now, we're just talking about population and sample, and there are variables, so there are some information there here. But as we move on, we'll actually see what this sampling inference means, and some other things in this figure as well. Okay, so the next question is that what should we study? So when we are interested in sleeping hours, what should we ask? Who should we ask? Type of question. So what would you ask? So there are different ways that you can probably ask this question. One of the possible questions would be, how many hours do you sleep a day on average? You can ask that question. If you're particularly interested in how many hours they slept last night, you can ask that way as well. But so that will be how you ask the question. Next question is, who would you ask? If you can study the whole population, here approximately 4,000 students, Truman body, if you can actually collect all the information from the 4,000 Truman students, that would be great. However, often this is quite expensive, time consuming, and sometimes it's actually not really as accurate as you think. For example, you are trying to collect all the information from everybody, but particular group of students, for example, they're just work too much, and so they're too busy. So those students will just tend to ignore the survey questions. So they're not going to actually answer your sleeping hour question. Then you're kind of missing the whole particular group of population from your sample. So it's not really necessarily a good way to approach often. So often taking a good sample from the population is the best alternatives. Again, on the right up corner of the slide, you can see a figure that represents population sample. Now we're going to focus on variables a little bit. There are a few different types of variable, qualitative or categorical variable, or quantitative variable with numeric values. For qualitative variable, there is an ordinal variable. For example, let's say you are asking the year in school at Truman. So there are possible values, possible answers can be freshman, sophomore, junior, senior, super senior, graduate students, or something like that. Um, this is a qualitative variable, right? Definitely it's not number, but at the same time, you can kind of think that it's a number as well. 1, 2, 3, 4, right? 4 is larger than 1, which means, seniors are actually stayed at Truman longer than freshmen. So it has a little bit of order thing going on. So this type of variable, we call that ordinal variable. On the other hand, nominal variable has just categorical values that has no order. For example, race or zip code. Sometimes, you thought that zip code is a number, but 63501 is not necessarily bigger than 63500, right? There's no actual numeric meaning or order. So race or zip code would be in this category as nominal variable. We think quantitative variable, again, quantitative variables are the ones that has numeric value, numbers, have two different ways we think, discrete variable and continuous variable. Discrete variable is the values, it has a values countable or finite number. The numbers of sibling can be an example of discrete. So because the answer can be 0, 1, 2, 3, and so on. And the hours of sleeping can be continuous because it can be between 7 and 8, but there are so many different possibilities in between. So those are actually belongs to a continuous example, continuous quantitative variable. Um, Again, on the slide, there are some additional examples there. So first one is major in this class. So think about your major. You might be a psychology major, you might be health science major, you might be accounting major, you might be a political science major. So what would those variable be? Categorical, or qualitative, or quantitative? It is qualitative variable. Would that be ordinal or nominal? Definitely nominal. Okay, so major in the class will be qualitative nominal. Second and third one, height and weight. What do you think? Definitely those are numbers. Okay, so quantitative. And if you think about height and weight, the possible values for height and weight, between uh, 5 feet and 6 feet, there's so many numbers in between, right? Those are actually considered to be quantitative and continuous variable. The number of kittens in the litter, 0, 1, 2, 3, 4, 5, it's countable, so it's a quantitative and discrete case. The time a patient spent in the surgery, the time again is you cannot really actually exactly measure it, but it only is meaningfully in interval. So any of those things actually will be continuous random variable. Height, weight, volume, time, length, and all those natural measure things will actually count as a continuous random variable. Continuous variable, sorry. Then we'll be talk about descriptive statistics versus inference statistics. So among statistics, there are two different categories, descriptive one and inference one. Descriptive statistics is graph or numbers to summarize the information in a data set. So any number of graph you're using to describe or summarize the data would be called descriptive statistics. On the other hand, the inference statistics utilize sample data to make generalization about the population. So estimation, testing, decision making, prediction belongs here. Again, looking at this figure at the bottom, we sample typically, again, studying everything in the population is too expensive, too time consuming. So we make a sample, the small subset of the population. And then from that data, so the actual data set, typically what we have is these data sets. We describe this data set, and then using that descriptive statistics, you'll make an inference. You're going to make a generalization about your population. That's called inference statistics. The next couple of concepts that we're going to talk about is parameter versus statistics. These both of them are actually names for a measure. So those are both measures. Parameter is descriptive measure of the population, and the statistics is a descriptive measure of sample. For example, population mean, we typically use the notation of mu for the population mean. So average. Again, population mean, since we don't really have the whole information of a population, we don't typically know what the mu is. So that's why we say typically unknown here. So diff is a population mean. And then for the sample mean, so actual data set, you can calculate the average. That's called the mean as well. But for the sample mean, we use different notation, which is X bar. Okay, so mu and X bar, both of them are mean, but this one's a population mean, mu, and then sample mean is X bar. Another name in general, mu is actually parameter because it's a descriptive measure of population. And X bar is statistics because this is a descriptive measure of sample. Okay, so this covers the section 1.1. Now you are ready to go ahead and go my stat lab and do the homework assignment 1.1.